I hope you found Victoria's talk last week on the effect of Brexit and product liability interesting. And welcome to this session on genomics and COVID-19. So what's ahead? Well, firstly, we're going to consider what is genomics. We'll then look at the role that genomics has played during the COVID pandemic, and then consider some of the potential product liability implications. So let's start with what is genomics. And before we do that, we really have to consider very briefly what is actually a genome. So a genome is an organism's complete set of DNA, including all of its genes. And there are around 25,000 genes in the human genome, containing over 3 billion DNA base pairs. Each gene provides the instructions for making proteins, hormones, immunoglobulins, and enzymes, which control essential communications and functions that keep our complex systems synchronized. So in short, a genome is a complete set of genetic instructions providing the blueprint for everything that happens within our bodies. Genomics is a cutting-edge process which allows us to identify and analyze variations in the DNA called single nucleotide polymorphisms, and today we'll call them SNPs. There are 4 to 5 million SNPs in a person's genome, and these may be unique or they may occur in many different individuals. There are more than 100 million SNPs in populations across the world, and a SNP may have no effect at all, or it can modify the proteins created by a gene, making the genes more or less effective. So far, over 150 SNPs have been identified as having a direct impact on our health. So genomics provides clinicians with more information than ever before to enable personalized interventions bespoke to a patient's unique biochemical needs. I think it's important for us to acknowledge that the UK is a worldwide leader in genomics technologies, as is the NHS world-leading healthcare system, which works towards predicting and diagnosing inherited and acquired diseases, and also to providing or working towards personalized treatments and intervention. We're all aware of the 100,000 Genomes Project, which was launched back in 2012, and also in 2017, where the NHS England Board had the strategy which they set out to build a national genomic medicine service to include various things such as a network of genomic laboratory hubs across the country, a national whole genomic sequencing provision, and ultimately a clinical genomic medicine service. So what are the advantages of genomic testing? Well, they're vast, and I've listed quite a few of them for you here, and we'll just highlight a couple or so. So they have the potential, genomic testing has the potential to transform lives by illuminating a patient's genetic blueprint, as I've just said, to improve a patient's health, to intervene with predispositions to certain diseases, save more cancer patients, for example, by more accurate and earlier diagnosis, and also more effective use of therapies, enable a quicker diagnosis for patients with a rare disease to avoid the so-called diagnostic odyssey, assist with informed prescriptions by matching a patient to the most effective medications for them, and also to reduce the likelihood of an adverse drug reaction. Let's now move on to the role of genomics during the pandemic. As Professor Oliver Pebus of the University of Oxford says, genomic epidemiology has come of age during this pandemic. So why is that? Well, genomics has allowed us to monitor the pandemic by identifying the new virus variants, revealing the origin of new strains, identifying the transmission chains from one person to another, and also really analyzing the pandemic on a previously unimaginable scale. The earlier the detection via genomic sequencing of COVID mutations in the virus, the more prepared we can be. So it really does play a crucial role and an ongoing crucial role for our safety and our way out, our get out card from this pandemic. I thought it'd also be useful to acknowledge the vital role of the COVID-19 Genomics UK, known as COG UK, which was rapidly established back in March of last year to deliver large-scale and rapid whole genome virus sequencing to local NHS centres and the UK government. It's an innovative partnership made up of hundreds of people and various organisations, and it supports 16 sequencing hubs across the country. It's also affiliated to the well-known SAGE. So just to name a few of the things that COG UK does, it provides genome data, associated sequencing methods and analysis tools to inform public health actions and policy decisions. It hunts for mutations associated with changes in the biology of the virus. That could be, for example, associated with vaccine failure and alterations in disease severity. Prior to the pandemic, the largest data set for real-time genomic viral epidemiology during an epidemic was less than 1,500 genomes. And this was for the West African Ebola outbreak, which was sequenced between 2014 and 2016, so less than 1,500 genomes. COG UK surpassed this total within the first month of the pandemic, and it's so far sequenced more than 137,000 genomes. So you can see just how far we've come on through this technology. So no more praising of the UK, but actually the UK accounts for 45% of the over 360,000 publicly shared COVID genome sequences. Iceland has to date sequenced all of its positive COVID-19 cases, which is a remarkable achievement. But surprisingly, the US is behind in this technology. And Biden admitted when he was president-elect as follows: "We, the US, simply do not have the kind of robust surveillance capabilities that we need to track outbreaks and mutations." He then announced a boost in funding for such sequencing. There are concerns of significant gaps in such sequencing globally, and recently the WHO urged countries to increase their volume of sequencing to identify and trace new, potentially more dangerous virus variants, such as we know, the South African variant, and most recently, the quite worrying Indian variant. We'll now consider some of the potential product liability implications. And to do that, we firstly have to have a quick glimpse at pharmacogenomics. So this combines pharmacology, the science of drugs, and genomics, and it is a study of how genes affect a person's response to drugs. It does this by identifying genetic markers that increase our risk of adverse drug reactions, and by identifying genetic markers that reduce a drug's effectiveness. At the moment, we all have drugs where one size fits all. We have our paracetamols and our ibuprofens. But the aim of pharmacogenomics is to develop effective, safe medications and doses tailored to a person's genetic makeup. The focus is to have in the future the development of tailored drugs to treat various diseases such as cancer. And we have one example already, such as Herceptin for cancer drug treatment. So with the backdrop of pharmacogenomics, we can now consider potential product liability claims. And one such example is from the US back in 2011, where the plaintiff made allegations about pharmacogenomically based risks. The plaintiff claimed that she had a variant gene, CYP, which could not metabolize the defendant's drug, as well as most of the other people taking the same drug. She alleged that the drug was defective, not because of anything inherent in the drug itself, but because it was less effective due to her own peculiar genetic makeup. The claim failed. I'd like to call these types of claims genetic variation claims, and at the moment, they're simply not considered legitimate product liability claims. This is unlikely to change until the FDA or the MHRA or other similar regulatory authorities decide to assess drug approvals and contraindications on the basis of genetic subgrouping. But obviously something that may well happen in the future. And talking of the future, I have my genetic crystal ball predictions to end with. I think we can see the use of genomics in the future to detect gene mutations in people. And there are bloggers talking about us in the future being able to identify persons at greater risk, for example, of idiopathic mesothelioma. This could be a real potential game changer for asbestosis or asbestos litigation if gene mutation is considered a verifiable alternative cause. And we could see the same, who knows, for product liability litigation as well. I also anticipate cases where an expert will not be able to confirm or rule out a genetic or chromosomal abnormality as the cause of a plaintiff's condition. And could we see this as a potential product liability defense in the future? Hope you enjoyed this session, and many thanks for listening. Next week, Neil Block QC is going to talk about product liability and recall in the UK. Many thanks.